We're looking at polynomial division today, which is going to start out as this long division here, which is kind of annoying. But then I'm going to show you a shortcut for some of these division problems called synthetic division. So that'll be nice. But first, we want to review some of the information that this polynomial division can give us. So we have this factor theorem that says that all of these are equivalent, which means if you know one of them, then all the rest of them have to be true. Or if you know that one of them is not true, then none of these could be true. And so most of this you would probably already realize. So k is just any particular number. So let's say if k was 5, I think you already know that if x equals 5 is a solution 0, x-intercept root, all of these are equivalent terms. If x equals 5 is a solution, x minus 5 is a factor. We've seen that a lot. Well, and of course, what does it mean to be a solution or an x-intercept? It means that if you plug it in, you get 0. The one thing that might not be something you've seen as much is that if something is a factor, that means that when you divide by it, you get a remainder of 0. So you might not have seen that as much with polynomials, but it should kind of make sense to you. So if you think of numbers, if 2 is a factor of 8, 2 goes into 8, that means that when we divide it, we get a remainder of 0. 2 is a factor of 8 because we can put it as part of a multiplication problem for 8. And so when we do this division problem, there's going to be a couple different summary statements that the book will ask you for. So I thought I'd just show you this example and show you what the terminology the book is using means. So how we would normally write the answer to the division problem is what they're going to call a summary statement in fraction form. So you do this division problem, you do x squared plus 2x plus 6 divided by x minus 1. You get an answer of x plus 3, and then the remainder of 9, we have to write the remainder in a fraction, right? Hopefully you remember that from your previous experience with long division and polynomials. It's just like with numbers. Again, if you do 7 divided by 2 and you get 3 with remainder 1, that means 7 divided by 2 is 3 and 1/2. That remainder 1 you can write in the fraction over what you're dividing by there. Now, what they're also going to ask for is what they call a summary statement in polynomial form, and that's just the idea that division is always related to a multiplication problem. So back to the 8 and 2 and 4 example, if it goes in evenly, then you can write a nice simple multiplication problem, and that will work perfectly. If it doesn't go in evenly, if there's a remainder, well, so 2 does not go into 7 evenly, so 2 times 3 is 6. It's not 7, you're a little bit off. Well, how far off are you? You're the remainder off. The remainder of 1 is how far off you are. So if you do the 3 times 2, then just add that remainder on, and you would get the 7. That's the same thing with polynomials here. X minus 1 didn't go into this evenly, so x minus 1 times x plus 3 doesn't exactly equal this. But if I multiply them together, I get something very close. If I multiply those together, I'm very close to this. I just have to add the remainder. The remainder would be how far off I am. If you're not sure, you can always check this. You can multiply this out for yourself. Here you'll see x squared minus x plus 3x, so you get the plus 2x, and then you'd have a minus 3 here, so the minus 3 plus the 9 would give you the 6. Okay, so let's go ahead and do some division here. So we have to put the 5x squared minus 17x minus 12 inside the house, and then the x minus 4 out here. And then we're just looking at the first term. So we're seeing how many times does x go into 5x squared, or what do I need to multiply x by to get 5x squared? Of course, x times 5x is 5x squared. And then I need to take the 5x and multiply. And so I need to distribute it. So I get 5x squared here, and then 5x times the minus 4 is minus 20x. Now this is the step that a lot of people will make mistakes on if they're going too quickly. You need to subtract, but you need to subtract this whole thing right here. I wouldn't, in separate steps, do like minus in parentheses and then try to do the subtraction that way. I would just distribute the negative right away, because that's the part that people make mistakes on. So don't give yourself a chance to make a mistake. Just right away, as soon as you write one negative, just change all the signs of what you're supposed to be subtracting there. All right, and so then I can combine these like terms here. Those cancel out. The first part should always cancel out. And then I get 3x here. And then I carry down the minus 12. And I do the whole process all over again. Just look at the first terms. How many times does x go into 3x? X times what would give me 3x? And that's positive 3. Then I take 3 and multiply it by the x minus 4. And of course, that'll give me 3x minus 12. So then when I distribute the negative, remember, subtract the whole thing, distribute that negative, then I'm going to get a remainder of 0. So this one actually goes in evenly. There's no remainder. The answer is just 5x plus 3. And now, based on the fact that we got a remainder of 0, again, we know a bunch of things. A remainder of 0 is equivalent to several other statements. So let's talk about all the different things that we know. Because the remainder is 0, like I was saying, x minus 4 goes in evenly. That means that x minus 4 is a factor. Let's call this right here f of x. So we don't have to write it every time. X minus 4 is a factor of f of x. Well, if x minus 4 is a factor, that means we could write a multiplication problem that equals f of x. Let's actually see it. How could we actually factor f of x? We could factor this quadratic right here. I mean, I could just give that to you. I could say, take 5x squared minus 17x minus 12 and factor it. Well, what we know now is that one of the factors, if you did that, would have to be x minus 4. What about the other factor, though? Do you have to actually go through and do the guessing and checking and think about the different pairs to make that? No, you already know what the other factor is. It's 5x plus 3. Again, it's just like the idea, if 8 divided by 2 is 4, that means 2 times 4 is 8. The division, multiplication go hand in hand. It's the same thing here with polynomials. Okay, well, if we know a factor, then we know a solution. If x minus 4 is a factor, what solution do we know? We know x equals 4. You can use any one of these terms you want. They're all equivalent. Solution, 0, x-intercept, root. I'll just say root is a root of f of x. And then, well, what does it mean to be a root? It means that if I take 4 and plug it in, if I did 5 times 4 squared minus 17 times 4 minus 12, if I found f of 4, I would get 0. So getting a remainder of 0, knowing one thing, means I actually know 3 other things. All of these things are equivalent. You know 1, that means you know all of them. And well, like I was saying, that means that if one of them is not true, all the others are not true. Take a look at this example that was printed in here. This one didn't have a remainder of 0. It had a remainder of 9. So that means that we know when we divide it by x minus 1, it didn't go in evenly. So this one, we knew x minus 1 was not a factor. Let's call this one g of x. Of g of x. Well, if x minus 1 is not a factor, that means x equals 1 is not a root of g of x. And if it's not a root, that means when you plug it in, you don't get 0. All right? Again, because one of these wasn't true, because the remainder wasn't 0, all of these other statements had to not be true. You actually do know what g of 1 would be. There's actually another thing called the remainder theorem that says actually the function value is always the same thing as the remainder. So it's not a coincidence here that the f of k here and the remainder when you divide were both 0. Here, actually, we could say that g of 1 would have to equal 9. this remainder here would be the function value. You could see this if you take a look at this summary statement in polynomial form here. If you plug in 1 on the left side, should be the same thing as when you plug in 1 on the right side. Well, this part here would be 0. And so all you would have would be the remainder. All right. Normally we'd cover the remainder theorem more, but for distance learning, that's all you're going to get. All right, so let's take a look at this second problem here. Now this one is missing a bunch of terms. It goes straight from x cubed to a constant, straight from x squared to a constant. We're missing an x squared and an x term in the middle here. We kind of skipped some terms. It's helpful if you put those in there as 0 terms, as kind of placeholders to help yourself out. If you were really good and careful with like only combining like terms, you could do this without putting in the 0 placeholders. But it just helps things if you put zeros for any missing terms. And when we do synthetic division, I'm going to teach you a shortcut in a couple minutes here. For that, you would have to have these 0 placeholders. And you can do it with both parts, whether it's the inside part or the outside part. These 0 placeholders will help. Okay? And then, so x squared times what gives me x cubed? That's x. So then I multiply it everywhere by x. So x cubed plus 0x squared, and then minus x. And then make sure you distribute the negative. We're subtracting this whole thing, so distribute the negative everywhere there. And then I can combine these like terms. Those cancel out. That's just 0x squared. So I've just got an x right there. I can bring down the minus 5. Well, take a look at that. X squared into x. X squared doesn't go into x. To multiply x squared by something and get x, I would need a fraction here. So I'm done dividing. I'm ready to write my answer with my remainder. I can say that this is x plus x minus 5 over x squared minus 1. And that's the answer, or what the book is going to call the summary statement in fraction form. If you wanted to write the summary statement in polynomial form, you could, and it actually would be a way to check your answer. So what you would say is that what you're dividing by times your answer. So x squared minus 1 times x, and then add in this remainder, should equal what we were dividing into. It should equal x cubed minus 5. Well, if you're not sure if you did your division right, you can always check it. Let's check and see if this is actually true. So distribute this x here, x cubed minus x, and then plus x minus 5. Well, look at that. Those x's will cancel out, and we'll just get x cubed minus 5. So we know we did it right. It does work out. All right, why don't you guys go ahead and try this third problem that I've got for you here. Go ahead and try number 3 here. X to the 4th plus 8x squared minus 5 divided by x squared plus 2. Go ahead and give that a try. And you could have checked your answer yourself. Maybe some of you did that, but you can also check your answer here on the paper. Again, just watch out for those missing terms. Putting in those 0 placeholders can help you out. All right, so that was polynomial long division. It can take a little while. There's a shortcut for some of these division problems called synthetic division. Okay, it's just a quicker way to divide. Now, it only works, though, when we're dividing by linear terms, when we're dividing by something that only has x to the first in it. So this one right here, you could not have used synthetic division for. Let's see here. What about number 2? Could we use synthetic division on that one? No, because we're dividing by x squared. What about the first one? Yes, we were just dividing by x to the first, so we could use synthetic division on that one. This printed example, we could have used synthetic division on that one. If we're only dividing by x to the first, if we're not dividing by x squared, we can use this trick called synthetic division. Okay, so here's what we do. So we just copy down the coefficients. We list the coefficients only. So we say, there's all this work, all this writing that we did, writing all the x's over and over again. What if we just look at the coefficients, just the numbers, right? So we copy down the 2, the -5, the -1, and the 3, okay? And then what we're dividing by, we do the normal thing of thinking that x plus 3 goes with x equals -3. Again, we've done that a whole lot. The factor x plus 3 goes with the 0, the root x equals -3. And we put that outside here. So we list these coefficients. And there's kind of a box that we draw here. Okay. And then the first coefficient just gets dropped down. And then at each step, we're going to multiply this number by this number. And it's going to go up here, and we add these together. Okay? And then we're just going to keep repeating. So we multiply, and then the number we get goes here. And then these get added. And then we multiply those, and whatever we get goes here, and we add. All right, and then for writing out our answer, so we get all these numbers here. What do these mean? Well, I like to kind of work my way back up. So the last one is the remainder, and then this is the constant, and then this is x, the coefficient for x, and then this one is the coefficient for x squared. If we had another one here, it'd be the coefficient for x cubed, another one, x to the fourth. You would keep working your way backwards up. All right, so it's just a trick. Somebody just got tired of doing long division over and over again, and found a nice trick for doing it more quickly, called synthetic division. And it does only work for these linear terms, but what you'll see is that the kind of division we're going to be doing with polynomials a lot of the times is dividing by something linear. So we're going to have a day tomorrow where we're going to do a whole lot of division by linear terms. You'll see why tomorrow. So you never have to do synthetic division, but it's really going to save you a lot of time and a lot of work with what we're doing tomorrow. Okay, so let's try that on this problem here. So what we're going to do is, so this x minus 2, we're going to look at that and say, well, what's the 0? What's the root that goes with x minus 2? That's x equals 2. And so what we're going to have, now what I do, I put it in kind of a little box over there. So I've got the 2 over there. That's going to be what I'm multiplying by all the time. And then I'm just going to take these coefficients. So 9, -18, 16, 32. And then we're going to put a line down here. I also put a little line here because this one's my remainder, right? So I put a little line here to separate my remainder. Okay. All right. So then the first number just gets dropped down. But then after that, it's going to be the same process repeatedly. So we're going to multiply these two numbers, do 2 times 9. So we multiply diagonally, and then we place that number up here diagonally. All right. Now here's the thing to remember and to not get confused on. So when we did long division, we had to subtract, right? Long division, we had to distribute that negative to subtract. When we do synthetic division, what you're going to do is you're going to add, right? So it's going to be -18 plus 18 for zeros. Make sure you keep that straight. Long division, distribute that negative, subtract. Synthetic division, you're adding. All right, so then we just keep repeating this process. We multiply the 2 and the 0, multiply diagonally, and then place the result diagonally. And then we add 16 plus 0, 16. And then we multiply diagonally. All right, let's see here. Yeah, what did I do? I knew something was wrong. I didn't copy down that negative there, huh? That was a minus 16. That should have been negative 16. Thankfully, a nice easy fix before I went too far. So 2 times negative 16, multiply diagonally, and write the answer diagonally up there. And then add those numbers together. And I remembered the remainder was 0. That's why I knew I made a mistake somewhere. All right, of course, it's not always 0, right? I just remembered this one was. Okay, so now that we've got these numbers, we've got to turn these numbers into an answer, okay? So the remainder is 0. Well, if the remainder is 0, we don't have to write anything for that, okay? And then we're going to work our way backwards up. So this one is our constant. It's just a number. And then after that, we have x to the first, and then we have x squared. If we had to keep going, x cubed, x to the fourth, so on. So my answer here, I've got 9x squared. I don't have any x's, and I've got minus 16. And that is my answer. And of course, if you want to check it, every division problem is related to a multiplication problem. You can check, does 9x squared minus 16 times x minus 2 equal what we started with there? And so you can see you'd have 9x cubed, and then you'd have minus 18x squared, minus 16x, and plus 32, which is what we had up there. So it looks good. Okay. All right, now take a look at number 5. There's a couple things a little tricky about number 5. See if you can take a look at this problem here. Take a look at this polynomial and see if you can tell why this one's going to be a little bit trickier. There's a couple weird things about it. Well, first of all, hopefully some of you guys noticed these terms are out of order, right? That's a problem. Okay, if we're going to just copy down the coefficients, well, it would be a completely different problem if we just change those numbers around, right? So when we do this, we have to have these polynomials in standard form. We have to have the exponents decreasing, x cubed, x squared, x, and then the constant. So we need to flip-flop those. Well, then also take a look at what we did. Even if we flip-flop those, we'd have x to the fourth and then x to the second, x squared. X to the fourth, x squared. Something missing there. Usually after x to the fourth would be x cubed. So we're going to need a 0 placeholder for that. If we have any missing terms, we're going to need a 0 placeholder. So just like we did for this right here, for long division, again, it's helpful, but not necessary. For synthetic division, it's going to be absolutely necessary. So we need to look at this as x to the fourth plus 0x cubed, minus 10x squared minus 2x plus 4. We need the terms in order and zeros for any missing terms. All right, and then x plus 3 goes with x equals negative 3. So we're going to put negative 3 in the box here. And then we'll copy the coefficients, 1, 0, negative 10, negative 2, 4. And then draw the line down here. I put an extra line to separate off my remainder. The first one just gets copied down. All right, and then we remember the process. 1, we multiply by negative 3, and then add negative 3. Then we multiply, that's positive 9, and add negative 1. Multiply and add. Multiply and add. So this one doesn't have a remainder of 0, that's fine. All right. So we've got to write our remainder. We've got to have this 1 over x plus 3. And then again, we're going to work our way backwards. This was just a number, it's the constant. This is the x term, the x squared term, and the x cubed term. So we've got 1 here, minus x there, minus 3x squared here, and x cubed there. And that's our answer. All right. So why don't you go ahead and try number 6 now? So this one we are, remember, we can only do this if it's just x to the first. We are dividing by something with x to the first. We're not dividing by anything with x squared or x cubed on it. So you can use synthetic division on this one. So why don't you go ahead and try synthetic division? Just be careful. There's one little thing here. Remember, we had to kind of rewrite things on number 5 here. There's one little thing that you've got to do similar to that on this problem number 6. So be careful. But you go ahead and try number 6 using synthetic division. See how much quicker it is than long division. Right, and there is your answer for number 6. 5x squared minus 15x plus 47 minus 140 over x plus 3. Or of course it could have had plus negative 140 over x plus 3. Either way. And I just realized on the other page here we forgot to write the plus, didn't we? On that last problem. Should have been a plus on number 5 between the negative x and the 1. Sorry about that.